Hi, this is Sung, the Principal and Director of Sky Academy, and in the last episode we went through basically the log laws, right? We went through what the log laws are, how they operate. This episode I want to look at some specific examples where we actually use the log laws and we see them in action, okay, for specific examples. So I've got 3 examples up and they all kind of use different log laws, and we're going to see how they work and they combine together to help us to answer some questions. So the first one here, we've got x squared times x5 times x to the power of 5 times x to the power of 3. This is a simple use of which log law? Which of the 4? Well, it's this one here, isn't it? Okay, so let's just do that. So basically it says when you're multiplying numbers, you add the indices if they have a common base. Alright, so you've got x squared times x5 times x cubed, which is x to the power of 2 plus x to the power of 5 plus, x to the power of 2 plus the 5 plus the 3. Yep. So the indices, you add the indices together, which gives us x to the power of 10. Okay, so that's pretty straightforward. Let's have a look at the second one. This second one is kind of sneaky. It kind of allows us to use, for example, which log law is it? The third one, okay? Because we've got powers to more powers, right? So if we work this one out, I'm going to work down the page with this one here. If we work this one out, what we get is r to the power of 2, again to the power of 3. That gives us r to the power of 2 times 3, which is r to the power of 6. You've got q to the power of 1 times 3. All right. Now the 1 usually isn't there. I've put it there for this example, just so that you see what's going on. But usually what you'd see is it's q by itself. But if it's q by itself, it's q to the power of 3. And that would be q to the power of 3 times q to the power of 2 to the power of 4, which is q to the power of 8, r to the power of 1 times 4, which is r to the power of 4. Right? Now, when we multiply that, r to the power of 6 times r to the power of 4 is r to the power of 6 plus 4, which is 10. And you've got q to the power of 3 plus 8, which is 11. And which log law did we use to work that out? We used the first one. So we used a combination of the third one and the first one to work this out. Okay? Now, with this, what I want you to also notice is r to the power of 10, q to the power of 11 was your answer, but we could just as easily have written q to the power of 11, r to the power of 10. Right? And the reason why these two answers are just as valid is because 3 times 4, for example, 3 times 4 is also equal to 4 times 3, isn't it? Okay? And what's gluing, or what's the glue that glues the Q11 with the R10? It's a multiplication sign. So that tells you that whether the order doesn't really matter. Okay? So, yeah, so that's just something for you to know. So either of these two answers are valid, and the one that we'll probably use, or the one that by convention is probably the one that most people would like to kind of leave their answer in the form of, is the one where it goes in alphabetical order. So the Q comes before the R, so usually this form is the one that by convention is favoured, okay? But it doesn't have to be, okay? So let's just leave that. And then you've got this example here, right? And I'll go through this example again. This example will use a combination of 1, 2, and 3 of these different index laws. Alright, so let's have a look at how this operates. 5, so you've got 5 to the power of x to the power of 5, y to the power of 2 times 3. And this one, you use the index laws. X to the power of 1 times 2 is x to the power of 2. Y to the power of 3, again to the power of 2 is y to the power of 6, all over 15 to the power of x to the power of 3, y to the power of 7, right? Work that out and you get 15 x to the power of 7, y to the power of 8, all on 15 x to the power of 3, y to the power of 7. Now the 15s can cancel. Okay, do you see how the 15s cancel? Because 15 15 over 15 is 1 over 1, alright? But what we do here is that we subtract the powers. So it's x to the power of 7 minus 3 and y to the power of 8 minus 7, which leaves us with x to the power of 4, y to the power of 1. Okay, so that's how you do the index laws. That's how you use them. Alright, so in the next episode what we're going to be looking at is identities for indices, as well as what happens when we've got negative indices. So I'll look forward to catching you on the next episode. Thank you very much for watching.